tomorrow will be better. A 72 kg box slides down a 15 degrees slope, accelerating at 0.7 meters per second square. Find mu d. Dear friends, mu d here is a coefficient of kinetic friction. Follow me, dear friends. Solution. The first step to solving such problems is to draw some sort of a free body diagram, which due to time has already been drawn on the board. Now, if this is our slope here, 15 degrees, then it's been proven that there's a component of the weight which acts along the plane of motion, which has been proven to be mg sine 15 degrees if this is 15. And of course, mg cos, which should be a perpendicular component to this latter one, will act in this direction. Traditionally, the weight always acts vertically downward, irrespective of circumstances. Now, strange enough, the normal or the reaction force here is not what most of us would have expected, that for it to be directly opposite to mg. In this case, because it's an inclined plane, we will have it in this way. And of course, without going too far, you will notice that this aligns directly with mg cos 15 degrees. And of course, we have the friction force here. Now, first things first, the question makes mention of an acceleration. What force, which of these two forces is responsible for this? It is none of them. What is responsible for this acceleration is a resultant of this force. This is the first step into solving this question. So we will say mg sine 15 degrees minus, why minus? Because friction opposes the direction of motion, which is in this direction. So minus friction should give us, in accordance with the law, second law of Newton, F equals ma. So this should give us ma, where a now is 0.7. Now from here, I would like us to make friction the subject of the formula, and I'll tell you why. From here, friction is going to be equal to mg sine 15. I'm bringing this to this side and then bringing this way, minus m times a. And if you correctly simplify just this alone, we should arrive at 132.2 Newton, because friction is a force. On the other hand, how do we relate this, which we have now, to what we are looking for? We will say, but friction is also given by the reaction force, the product of the reaction force times this, which we are looking for. So make this a subject by simply dividing friction by the normal reaction. We will say again, but this normal or reaction force in this case is not equal to mg. It's equal to mg cos of 15 degrees. So everything should boil down to what? To friction, which is 132.2 divided by